In this video, we're going to be focusing on alkenes, the naming of alkenes. Of course, we know that alkenes are hydrocarbons. We know them because of their characteristic carbon-carbon double bond. Because of that, they are unsaturated. They are also known as olefins. So, if we want to name an alkene, for example, if we have this, for example, we need to number this first carbon 2, 3, 4, 5, and 6. So since it is 6, 6 means hex. When we treated alkanes, we said 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, 10 decane. So because of that, for alkenes, we change the suffix from "-ene" to "-ene". So 6 becomes hexene. Now, for us to locate where the double bond is, if we are naming from here, it's on the second carbon atom. If we're naming from here, it will be on 1, 2, 3, 4. It will be on the fourth. So we are going to choose in such a way that the double bond will take the lower number. So we will call this 2-hexene. Or some textbooks will write it as hex 2-ene. Both of them are correct. Another example, let's look at this molecule. Where should we number from? Okay, let's start from both sides. Let's start from the left first. If we number from left, we're going to have that the double bond occurs at 1 and 4. So 1, 4. If we are numbering from here, but if we start from the right side, we'll have that the double bond is going to appear on 3 and 6. So we'll notice that the lowest one is lower than 3. So we'll pick it as 1, 4. Since it's 7, it is heptane. But we have two double bonds. So instead of saying heptene, we're going to say heptadiene, which means there is 2 in there, 2 di. When we have 3, it's tri. When we have 4, it's tetra, and so on. If we have another example, here we have a pendant. Now this is a cycloalkene because of the double bond. If we are to name it, we're going to number the numbering of the carbon atoms around this ring must be done in the direction that will give the lower number, that is the locant, to the substituent group, these substituent groups. Now if we are numbering, we can start from here: 1, 2, 3, 4, 5, and 6. Now we have that at the fourth group we have ethyl, at the third we have methyl. Then we can name it as, should we say 3-methyl, 4-ethyl. Since it is 6, 6 is hex. Hexene, cyclohexene. Another this is 4-ethyl, 3-methyl, cyclohexene. Now, if we look at this, you can see that we have 3 here, we have 4 here. But in this case, we're going to pick, here is M, here is E. Well, E comes before M. So for this case, we're going to pick this as the actual name because E comes before M, irrespective of the number. So, but if we also want to say where this in is, we can say cyclohex 1 in. So that would be the name. Now, in this situation, we're given a name to actually draw the molecule. 3-bromo, 2-pentene. Now, we need to, this is the parent, pentene, so 5 carbon atom. So 2-pentene means that the second carbon atom, that is where the double bond comes. If we're numbering from here, 1, 2, 3, 4, 5, at the second carbon atom, that is where 3-bromo, it means at this 3-bromo, we have so if we still want to write it, maybe put it straight, we can say 1, 2, 3, 4, and 5. At the second carbon atom, we have this, and then we can now have 3 at the third carbon atom, bromo. All these are now hydrogen. Remember, each carbon atom must have maximum of 4 bonds. So this one has 1, 2, 3, 4, complete for this one. This one has 1, 2, 3, so we have to give him extra 1 to make it 4. So 3-bromo, 1, 2, 3. At the 3 you see bromo, 2-pentene. So the second carbon atom, you have this. Thank you. So in case you've not subscribed to my channel, please just click the subscribe button. Thank you.